In this video, we will also discuss few families of programmable ICs and how we can get required output from non-programmable ICs. And we will learn all these things maybe with the help of data sheets or also with the help of this IDE software, which is belongs to STM32 family of microcontrollers. So first of all, let's see. Here in the diagram, you can see on the left side, I am having a non-programmable IC, and on the right side, I am having a programmable IC. Maybe you can see that with the help of pins, yes, by viewing it, you can see, yes, it is programmable IC and it has only 8 pins, maybe sometimes 16 pins. They are non-programmable IC, but it is not sure because sometimes it is possible that if a microcontroller or a IC has 8 pins, then obviously it is possible that it is programmable IC. So don't believe on the number of pins. Let me take you to the some data sheet. Okay, so here is this is the boost converter and TPS 631000 DRLR. This is non-programmable IC. Why we call them non-programmable IC? Because it has some specific function in the circuitry, and it have some fixed function, and also it is hardwired IC. Hard means like we cannot program them at all. Then the question is how we can get the required output out of it if we cannot program it. We can see its data sheet, then I can make you understand that how we can use this IC for the requirement of our own purpose. Okay, this is the IC and it is power density buck boost converter IC. It can take input 1.6 to 5.5 as an input, and it can gives output of about 2 amperes and 3.3 amperes if we keep this input voltage above 3, and if we keep its input voltage like equal to or a bit more than 2.7, then it can give me output of 1.5 and 3.3. But how? Because I cannot program it, I cannot give command to it, then how I can operate this thing? Let's see its pins first. So yes, in this page you can see that this IC, which is a boost converter IC, buck boost converter IC, we cannot program it. Even you can see its pins. Its pins are like V out, power stage out. We can get the output from here. Inductor switching mode, node LX to LX1. Here the inductor will be connected. V in, supply in, enable pin, mode, ground, FB. Not a single pin is having like TX, like transmitter, RX, or something like SPI or CAN bus. No pin are having this configuration, so we cannot program it. Then how we can use it for on purpose? Let's see its schematic. This is the block diagram of it, and here is the schematic of it. Okay, all these pins are here. LX1, LX2 inductor is connected, V in, power in is coming, mode, enable, whatever, ground, feedback, voltage out. That's it. So here in this table, we can see that if we are having 2.7 to 4.3 input and 3.3 output, 1.5 amperes output. Okay, good, very good. Here we can see that if I want that my output of this IC will vary, or I want a different output in voltage or amperes, this is the resistor R1, which is going to be changed. We can change its value. Only by changing its value we can fix it required output for us. There is no other way. Yes, in some cases the input and the inductor value also play very important role by taking a required output, but for this specific IC it have some specific function for buck or boost converter. So by changing only this R1 resistor value we can change its output, but how much we will change, how it will happen, this can be explain in this one, adjustable output voltage. Here they mentioned very precisely that the R2 resistor, which is between feedback and ground, we cannot keep its value more than 100 kilo ohm. Okay, all right. Here we can see it is 91 kilo ohm. All right, fine. We will keep it at 91 kilo ohm. Very good. But for R1, by using this specific formula, we can change its output value of voltage and also for current. Here you can see there are three values: voltage from feedback, V out voltage, how much we want. R2, we cannot keep it above 100 kilo ohm. R1 we can change, and then we can find out precisely how much output voltage or current we can have. So in this way you can understand very clearly that without changing or without programming this IC, we are changing or we are getting the required output from here. But for the detailed scenario or how much value precisely it will give, you can understand these tables and these data sheet easily. You don't need to understand each and everything 100%. No, only if you could understand 15 to 20 or 25% of the data sheet, then you can obviously understand the not the programming, the working, the required output for yourself or your project. I can take another example of this IC, three-phase sensorless sinusoidal fan driver. This is a specific some driver. It also have some 8 pins, and these pins are almost like voltage, input, output, feedback, maybe some enable pin. They don't have, okay, these are the specific ground, motor out, power supply, speed PWM, LDO output, speed output signal, motor out C, motor out B. So not a single pin which is transferring something like data, like as I told you before, transmitter, receiver, SPI, I2C or CAN bus. Again, this is the driver, like motor driver or motor controller. So we are basically controlling the motor. Yes, obviously it also have some schematic. Maybe I cannot get it here. Yes, in this data sheet they don't have, and maybe if I want to change something, my required output, we can also change its some connected component out of it. Obviously inside of the IC we cannot change, but the outside components in this one, as I showed you here, that these two resistor, yes, by changing some values of few components around it, outside this IC, outside this box, yes, we can change the required output for us. Now, we will talk about the programmable ICs. Programmable ICs are very interesting and very important for us. This is the LCSC electronics. Let's go to the embedded processor view all. Already I opened this page. So these ICs, like digital signal processors or microcontrollers or programmable logic devices, FPGA, CPLD, we can program them. I will talk about microcontrollers. Let's go to the microcontroller. I have already opened one. These all the microcontrollers which can be programmed, and which obviously they can be programmed, and I have already opened one microcontroller. This is STM32F446V86. Here you can see how much things it have inside in one little IC. So they have RAM, flash, like they have some RAM where you can save your data. They have USB outputs from its pin. Obviously not, you cannot see, but by using this pin you can make a little IC and a little PCB, those PCB where you can connect some USB. It have 17 timers, 3 analog to digital converters and 20 communication interfaces. I will take you to get the complete explanation, not this for the specific IC, but for the same series, for the same family. I am going to take you this STM32 block IDE. Here I will show you what else you can see in one single piece of IC. Let's take anyone. I am more like to STM32F4 series. I like this one. Let's take anyone. If they have it here, which is active. Yeah, it is active. Let's take this one. Okay, this IC is high performance access line ARM Cortex M4 blah blah blah. There is some little explanation about it. If you want, you can understand it. Basically, this platform which I'm using, it's like, I will make it a bit lower here. Okay, this is STM32 Cube IDE. This is the software which is totally free software, and by downloading this software you can just make a project here, and here then you will have to like open the file, and they will ask you that what do you want to select, the board, the examples, or the specific STM microcontrollers. So I select this one. Let's see what else we can open next. Maybe we have to just take a project name. We can just keep electronics, ELEC, elect, then finish. It will take some time to build because it is giving us a series of commands and the header files and the declared files. Declared files means that which the peripherals and the things which we can use in this IC, their functions are already built in, so we just need to pick and drop functions and to make our own project. uh, okay okay, this is here. This is my IC which I select, like STM32F4 series IC. Here now I will show you that how many things it have inside of it. DMA, GPIO, yeah, I will make a specific separate video for this thing where I can explain you all these things. So all these things they have here, and analogs, analog to digital converter 1, timers, these different types of timers are there. Then how you can connect this IC with the outer world. See, three types of I2C, 1, 2, 3, SPI, three types mean three different peripherals of SPI connection. There's USB, one connection, USART. So there are three different USART communication, three for SPI, three for I2C, one STIU, then one USB. Now you understood that those pins are how much useful and how much working we can get from a little IC. So yes, I will just give you an overview of this thing. You can also set the clock from here for yourself. This is the project manager. A lot of things are here which I don't want to explain right now for this. Okay, in into the short, let's go to the multimedia, I2S, computing, CRS computing is working here. There are a lot of how we can say the software which we can put it up and program them. Basically, if I will click here, it will start downloading, not downloading, it will start how I can say that installing it somehow, because STM32 on this platform they don't install each and everything. Yes, if I will click it and I will say yes, then it will start installing that specific on this IC. So that is a very big world, and this is specifically for STM32 series. So now you understood that how much big difference in one IC in programmable and non-programmable ICs, and now you understood that how many things you can do in programmable ICs. So that's why a little IC can have hundreds of functions, I will say. So that is the main difference of an IC, programmable IC and non-programmable IC. I think so now you understood that the main difference, and in later videos I will try to explain my how I can say this STM32 Cube IDE. And here I will say that if you understood well, you can like it, you can share it, you can subscribe it, and you can also tell others that they can learn a lot from this channel. Thank you so much.